Today we're going to learn about scatter plots, and scatter plots are super, super easy. Scatter plots are just like the name sounds. What do you hear when you hear the word scatter? All over the place. And that's exactly what we're going to be seeing today is dots all over the place on a graph, okay? So what is a scatter plot? Why do we use it? Right here it says, a scatter plot is a graph of plotted points that show if there's a relationship between two sets of data. In this example, each dot represents a person's weight and their height. So look, what's on the x-axis? Weight. What's on the y-axis? What do y'all think? The taller I get, what's going to happen to my weight? I'm going to gain more weight, right? Because I become a bigger person. So is there a relationship between weight and height? Yes. Do y'all see that the dots are scattered, but they are moving upward? Yes? Yes or no? Okay, so this scatter plot is showing that the more you weigh, the more you weigh, you tend to be taller. Sorry, I can't get my words out today. All right, so it's going to show different types of relationships. So everybody look. There are different types of associations. If the dots are moving in an upward manner like this, what are we going to call that? Positive. And if they're forming a straight line pattern, did I say straight line? A straight line pattern. So is this making a straight line pattern? Yes. Yes, that is called a positive linear association. It doesn't mean that it's going to make a straight line if I connect the dots. It means that they're moving in a straight line pattern. Okay, what is this one going to be called if it's going down? Negative. Is it moving in a straight line? Yes. Yes, so that's negative linear. This right here is a pattern. Does everybody see that the dots go down and then they hook back up? That is called non-linear, meaning there's a pattern, but it's not moving in a straight line. And then what is this going to be called? No association. The dots are literally everywhere. They're all over the place, and they're not related. So this would be like if I want to know if there's a relationship between your height and your grade in math. What do y'all think? Absolutely, there's no relationship. I'm going to have short people who are doing great and short people who are not doing great. Right? I'm going to have tall people who are doing great and tall people who are not doing great. There's no relationship going on. There's no association. Okay? That's how easy today is going to be. Again, if it's moving upward, we call it positive. If it's moving in a straight line, linear. If it's moving downward in a straight line, negative, linear. If it's moving in a pattern but not a straight pattern, we call it nonlinear. And if the dots are all over the place, there's no relationship. You can either call it no association, or they might say no correlation, which means the same thing. Easy, yes or no? Are we good? All right, that's pretty much what we're learning today is the different types of patterns that scatter plots can make. Go ahead and turn the page. Now we're going to answer some questions, and I don't want y'all to say the answer out loud. I want everybody to have time to look at it themselves and answer it. All right. It says, data was recorded on the age of drivers and the number of car accidents per 100 drivers in the year 2009. The data is shown in the scatter plot below. So everybody look at the scatter plot. Do you see a pattern, yes or no? Yes. Okay, let's answer the question. Do not say the answer out loud. What is the best description of the relationship? You're going to either circle positive, negative, or no association. Don't say it out loud. Circle what you think. If you need to refer back to the first page, you can at the bottom to show you. So you can look right here at all these types of associations. Okay, what did y'all think? B, negative. Why did we pick negative? Because the dots are tending to go down. Okay, so what's happening is people are getting older. They're tending to have fewer accidents because they become a little bit better drivers. Now, circle this dot right here. I want to talk about this dot. This dot is called, everybody's eyes up here, this is called an outlier. An outlier is part of the data, but it's kind of an exception to what's going on. Okay, like you have somebody who's 23 years old and they still had an accident. It happens, right? So yes, you look at it, but it's an outlier and you kind of don't include it in what's going on. So you just kind of look, everything else is following this trend. Okay? All right, I'm going to give you a second. I'm going to read this to you, and I want you to pick the answer, but I don't want you to say it out loud. Okay? So it says, what is the best description of the relationship between age and the number of car accidents? A says older drivers tend to have fewer accidents. B says older drivers tend to have more accidents. And C says there's no clear relationship at all. So I want you to pick which answer you think it is. Okay, what do y'all think? A. As people are getting older, what's happening? They have fewer accidents. Very good. That's all we're going to be doing today is interpreting scatter plots. Okay? All right, let's go to the next one. Dexter's class recorded data on test grades and shoe sizes. The data is shown in the scatter plot below. So everybody look at the scatter plot. I don't have everybody's attention. Everybody look at the scatter plot. What is the best description relationship between students' shoe size and their test scores? I want you to think about it, and I want you to pick your answer. Do not say it out loud. If you need to go back to the first page to look at these, you can. All right, what do y'all think? C. There is no association. Why? Because, guys, it doesn't matter what shoe size you have. That has nothing to do with your test scores, right? All right, I'm going to let you read the last part. It says, which statement is the most accurate interpretation of the association? A says, students with bigger shoe sizes tend to score higher. B says students with bigger shoe sizes tend to score lower. And C says there's no clear relationship. Pick your answer. Okay, what'd y'all think?
C.
C, very good. All right, turn the page. Sam measured the height and petal length of all flowers in his garden. Y'all know what petals are, right? Like the little things coming off the flowers? Okay? It says, what is the best description of the relationship between height and petal length for Sam's flowers? So I want you to look at the graph and answer if it's positive, negative, or no association. Don't say your answer, circle it. Okay, what did y'all get? A, positive. Why is it positive? Because the dots are tending to move upward. Just like slope would be positive, it's the same thing, okay? All right, the next question says, which statement is the most accurate interpretation? Taller flowers tend to have shorter petals. Taller flowers tend to have longer petals, or there's no relationship. Pick which answer shows this graph. Okay, what'd y'all pick? B. Taller flowers tend to have longer petals. Okay, the last question says, what is the best description of the relationship in the scatter plot below? I'm going to give you a second to read the answer choices, and pick your answer. Okay, what do y'all think? B, negative. Why is it negative? Because it's moving
Downward.
What is nonlinear? Remember, nonlinear is a curved pattern, going up and down or down and up. Does everybody understand?
Yep.
This is a very easy assignment, and these questions are STAR type of questions. They are that easy on the STAR test, some of them, okay? So you're going to go to your Google Classroom. I will post your assignment, and then you will get it checked with me.